One of the cool things we decided to go out and do the other night was went over the ocean, especially here on the Pacific Ocean, are having where you get these bioluminescent waves. And so as the waves are rolling in, they crest over, and there are just bioluminescent organisms in there. And so you'll see this kind of blue streak that just kind of rolls along as the waves are crashing in. And so we went out and were able to do that. It's just kind of nice, one, to get outside and enjoy creation, because I think that's what God has designed us to do. But just kind of cool to be able to do that as a family, because I've seen a lot of things in my life, and it's a little bit hard to impress me. And I was really impressed to see that. So it's been fun being able to find things to go out and do with our family, go out and take hikes, just enjoy the time talking. We spend a lot of time around the meal table because we're at home all the time. And so I hope you're finding ways to enjoy connecting with the people that you care about, the people that are important with you, even in this, even as things are just weird in the United States right now. It's also given me time to do some work around the house, working on getting my garage rearranged and cleaned out, and also building a shed so that my house is a little bit better organized. But at the end of the day, we do want to be able to do our work, and ultimately we're here talking about how science and creation work together, and how can we use that to point people to the truth of Christianity. And so I'm kind of excited today because I get a chance to talk about something that I have spent a lot of time thinking about. What is it what are the chances of finding life out there, and what would it look like if we do, and what can we know based on the science that we see today? And one of the very interesting things about that is that if you go by what science fiction has shown, you look at the Marvel universe, you look at Star Wars, Star Trek, basically any type of spacefaring movie, and there's just life everywhere. In fact, you got all sorts of different kinds of planets. You've got molten planets where people are mining things. You've got beautiful, lush planets. You've got desert planets. You've got water world planets, all sorts of different planets out there. And, it got me thinking a couple of years back, what can we tell about what a day would look like on a different planet? And, as we go out, astronomers have begun to find planets that are Earth-sized, that have at least this potential of being able to host life. And if there's a planet habitability laboratory. You can see the credits there on the slide. But as you look at this planet habitability laboratory, they've got this page where they show all the potentially habitable planets and ranked by distance from the Earth there. And you got Jupiter for scale, and you got Earth and Mars and Neptune, just to kind of see what these planets look like. And if you look at those planets over there, you've got Kepler 186f on there, you got Kepler 62f, TRAPPIST 1, F, E, and G, all sorts of different planets that are presumably, or at least have the potential to be habitable. And you notice that some of them are cloud covered, and some of them have water on it. And if we go kind of just look specifically at Kepler 186f, there's this graphic where it shows it right next to Earth, and you see that it's got clouds and little bits of land masses down there, and covered in these beautiful blue oceans. And at one point in time, right below this on the website, if you just go down, it had this view of what the sunset would look like on Kepler 186f. And it's just because Kepler 186 is a star that is it's a red dwarf. So it's a much smaller star, which means that the planet is much closer in. It's going to be a much more red light. And so this is presumably what the planet would look like if you're there on sunset, or you're there around sunset. And what's interesting is, you look at this and it kind of communicates this idea that these planets are just teeming with life everywhere, that where we get something that's remotely Earth-like, they're just teeming with life. And it got me thinking, before I kind of address whether that's the case, I wanted you to just kind of spend a couple of minutes thinking about what do you think are the most mundane things here on Earth. List the 3 most mundane things. And then if you could think of, just kind of for your benefit, 3 of the most spectacular things you can see. I mean, I would put the bioluminescent organisms right up there with some of the most spectacular things I've seen. But as we go out and look at these other planets, the imagery and the description of them, I mean, how could there not be life on Kepler 186f? I mean, you look at it there and it's got this ocean, clouds, sunset. I mean, there's got to be life there. And one of the things that if you're a little bit observant, you'll recognize is that the picture of the Earth is an actual picture. The picture of Kepler 186f is what that same setting would look like if it were identical on Kepler 186f, because you'll notice that the islands are in the same place, the waves are in the same place, the clouds are in the same place. So this is just an Earth-based picture put through filters that would presumably just account for the different colors of light coming from the star. And so that really does kind of raise this question, as we look at all of the different planets out there, again, the only difference here is the type of star that they're orbiting, and that's what affects how this picture looks on all these different habitable worlds. So that raises the question, what would a habitable, or what do these habitable worlds look like, or potentially habitable worlds look like? And the short answer is we actually have no idea. In order to make that determination, we have to have an instrument that would allow us to at least measure the light coming from the atmosphere of these planets. And even more, to get a picture like this, we would have to have light coming from the surface with sufficient detail that we could map out what the surfaces look like. And while we may get information about the atmospheres with instruments that are built within the next maybe 20 to 30 years, the ability to map out the ground or the surfaces of these planets in any sort of detail, that could very well be a century away. I mean, probably outside my lifetime before that happens. And so the short answer is, if we want to ask what would a day look like on one of these other planets, the answer is we have no idea. All we can do is make some educated guesses. But the reality of it is there are so many factors that go into the way the Earth looks and the environments in which we see that it's almost impossible to know what they would look like on another planet. Now, we do get some insight if we go out and look at Mars and Venus in our solar system, and we find a very different picture. And what that has kind of told me is that if we want to be careful, if we want to do that, we do have to be a little bit careful that we don't take for granted what we have here on Earth. Now, part of the challenge, I was telling you that it was going to be probably decades, if not centuries, before we get that information, is that if you look at a plot of all of the different planets that have been found from outside our solar system, and you put them on a graph where you've got the length of the orbit, or how long it takes the planet to orbit around the star on the x-axis there, and the mass of the planet in terms of Earth masses on the y-axis there, you can see you got all the red ones kind of clustered up there at the top, the blue ones clustered at the bottom. But you'll notice that basically the bottom right-hand side of this whole plot is blank. And that's because we don't have the ability to detect planets down in this region, or not with any sort of consistency. And if we now go and put our planets from our solar system on there, you see Jupiter's kind of right at the bound of what we could detect. Saturn, Uranus, the Earth, those are all well outside the range of what we could detect. And so it's just going to be a long time before we have the technology that would allow us to make measurements of what we will find on these other planets. So that kind of raises the question, how do we, or what can we learn as we think about what goes on these other planets? And this is where my question of what do you find are some of the most mundane things? If I were to go out and list it, I would put as mundane things that are just kind of run-of-the-mill ordinary. I go pick maybe dirt, maybe air, and maybe water. I mean, basically, no matter where you go, you got something, dirt, sand, something like that. You got air around everywhere. You can't get away from it here on Earth. And there's just kind of water everywhere. In fact, if you were to, even in the driest places in the world, you could get water out of the air if you knew how to do it. And so these are kind of three things that are just ubiquitous across the Earth. We can find them anywhere. They're kind of run-of-the-mill. We almost can't get rid of them in a lot of environments. And as I began thinking about these three things, excuse me, as I began thinking about these three rather mundane things, I recognized that they actually give insight into what it takes to make a habitable planet. And I think they actually point to a creator who's fashioned this planet for our purpose. And let me explain why. So let's take a look at water. I mean, water is one of these very, again, ubiquitous liquids here on Earth, but it is an incredibly remarkable liquid. It's an incredibly remarkable substance because it has a gas phase, a liquid phase, and a solid phase. And even in those phases, the way that water behaves is unmatched by any other molecule known to man. It's got an incredibly high heat capacity. It freezes from the top to the bottom. It absorbs or dissolves incredibly wide range of substances. And then there's a whole long list of things you could say about this incredible molecule. And kind of importantly is that it is liquid in the range where all of the biochemical reactions that life requires, water is liquid in that range of temperatures. And so it is ideally suited to host or provide the forum by which life originates, grows, and thrives. And so as we look at water, what are some of the things that we learn? I just think about the water cycle, and I'm reminded of this passage in 2 Peter. It says, "For they deliberately overlooked this fact, that the heavens existed long ago and the earth was formed out of water and through water by the word of God." Now, I don't think that's saying that God made water and then made everything else, but I think it's pointing to how important water is for the functioning of life, particularly life here on earth. And so as we go out and look at this, what do we learn? I mean, you go out into the ocean and you see this deep blue expanse where you've got clouds in the sky as the weather fronts move along and air masses are moving and creating clouds. And you've got, you could get places where water is just flowing down from the mountain. And this is a place where I happen to be able to visit. And what was remarkable about this is that as you stood off to the right or away from this waterfall, the temperature was about 20 degrees warmer than if you stood downstream, not where the water was hitting you, but just the water was able to cool off the atmosphere that rapidly that you could detect it. Or even as you're sailing along through the cold waters of the north, you find these incredibly beautiful icebergs, that there's this just vast range of the way water looks and behaves. And yet, as we begin to take our scientific understanding and probe how does this molecule work the way it does, we find that water has a pretty remarkable property. It's made of one oxygen and two hydrogen atoms. And normally you would expect any sort of molecule or a molecule like that, where you've got one central atom and two joined to it, it would form in a line. That's just the simplest way for things to be configured. And so that's kind of the expectation, what you might expect to see for oxygen and hydrogen and the way they line. But they don't. The two hydrogen molecules are actually, I think it's about 109 degrees that are the angle between those two bonds. And what you end up with from that is you kind of end up with hydrogen on one side, and you've got these lone electron pairs on the other side. And so water has this polar nature to it, and that it's got a charge on one side and an opposite charge on the other side. And what that allows it to do is actually bond to other water molecules. If it were not able to do that, it would just be a gas. In fact, we can go and measure that if we look at, if we go along the periodic table, and you look at the elements right below oxygen and right below fluorine and right below nitrogen and right below carbon, and you say, okay, look at how those molecules behave. You see that for carbon, the black line down there on the bottom, that the boiling point goes down, which means that whatever this substance is will boil and vaporize at a very lower and lower temperatures as you get up to that top layer of the periodic table where the carbon is. For nitrogen, it bonds to 3 hydrogen atoms. It decreases in boiling point until you get to nitrogen, in which case it goes up a little bit. And you would expect water, which is 2 hydrogens, to be a little bit further, and then fluorine would be the largest in there. But what you'll notice is that as you move up towards oxygen, when you go from sulfur up to oxygen, the boiling point goes way up. And that's what allows it to be liquid at the temperatures where we are. And that's what gives it the remarkable chemical properties that allow it to have all the things that life needs. And what's interesting is, as scientists have looked at this, they've kind of gone in and explored the what happens to oxygen, particularly if the laws of physics were different. And what they've shown is that if the mass of the up and down quark, and I'm not even going to talk about those except to say these are kind of the fundamental building blocks of all of the matter that we see in the universe. If the masses of those two quarks were 1 or 2 or 3% different from what they are, you would end up with a universe with basically no oxygen or carbon in it. And so what we see is that as we look at this water molecule, we see evidence for fine-tuning or purpose or design in the universe. That water, with just very small changes, we get no substance like water anywhere in the universe. And if you don't have water, you're not going to have life. And so even looking at this one kind of mundane substance, as we dig and probe into it and understand scientifically how it works, we see evidence for fine-tuning and purpose in our universe. Now, as I was thinking about these other, so we got water, we can talk about the atmosphere, we talk about air. Again, that's a pretty mundane thing. You go out and you look at the sky and you tend to just look through and see blue. Again, that's largely a lot due to, some of that's due to the oxygen, but it's due to how molecules scatter things. That's why it looks blue. But that's not really the point I want to draw out. When we look at the atmosphere, one of the dominant components of our atmosphere, not one of the dominant components, one of the important components of our atmosphere are actually carbon-based molecules. Methane, carbon dioxide, these are greenhouse gases that dramatically affect how Earth works. If we get rid of all the greenhouse gases in our atmosphere, the global surface temperature of Earth drops by about 20 degrees Celsius, becomes freezing, and life basically becomes impossible here on Earth. And so as we begin to investigate, we actually see this to me gives me a picture of how the heavens declare the glory of God and the sky above proclaims his handiwork. Because as we look at through the atmosphere, we get some of the most spectacular scenes that I've seen in creation. Here I was out able to look out over the ocean, and I just found this picture very remarkable because you get this one side where it's just lit up very well, and on this other side it's very dark, kind of this contrast of light and dark in a rather spectacular sunset. And as the sun went down, the sunset got even more spectacular than that. But in order for these sorts of things to happen, we need to have an atom like carbon. Now, carbon, as you go and analyze, it's got an atomic number of 6, which means there's 5 elements with an atomic weight less than carbon. When you look at the most abundant elements in the universe, you got hydrogen and helium. Those are the 2 lightest. You would kind of expect carbon to be relatively low, except that as astronomers have gone and looked and understood how carbon is produced, we actually see this very fine-tuned balanced nature of the laws of physics so that carbon is produced abundantly in stars. Because in order to get a carbon atom, you have to take 2 helium atoms, combine them together, have a third one come in and hit it, and that's what produces the carbon atom. But in order for that to work efficiently, 2 helium atoms have to bind together into a beryllium-8 nucleus. But that's an unstable nucleus. It doesn't stick around very long. But the fact that it sticks around at all allows a lot more time for that third helium atom to come in and to make the carbon. And it does so in a way that amplifies the rate dramatically. But even at that, in order for that process to happen rapidly, there needs to be a particular type of energy level in the carbon atom that accelerates or causes, it's a resonance state that allows the carbon to form more rapidly. But this isn't the end of the affair, because if another helium atom were to come in and there were a resonance state in the next atom or the next molecule, which would be oxygen, all of the carbon would just burn into oxygen. And it turns out that if you want to have a universe with abundant oxygen and abundant carbon, these 3 fine-tuned states, the beryllium-8, the energy level in carbon, and the lack of that resonant energy level in oxygen need to be the way they are in order to get an abundance of carbon and oxygen in the universe. And lo and behold, we see that the universe has just that state, just those 3 particular set of states. But more than that, as we just go out and look, this particular remarkable atom is what provides some of the most spectacular views in creation. This is a picture, and you kind of think, what is that? And it's a few years ago, I was stepped outside, and there was this sunset, and there were these kind of wispy clouds as the sun was going down, and it just looked like the sky was on fire. And I don't know, maybe other people who go out and spend time looking at sunsets a lot see this off, but the reality is I've seen something like this about twice in my lifetime. But it's just spectacular. I mean, to look up at the sky and it looks like it's just ablaze. I mean, I love fires, and I love seeing, and to see that in a way that you just see it across the entire sky, it does just draw me to recognize, wow, not only did God fine tune the universe and the earth for our habitability, he's also made it so that it's incredibly beautiful and just visually compelling and remarkable things to see. And so as we change or shift into that third kind of mundane thing, dirt, we take dirt for granted, and there's lots of kinds of dirt. There's sandy dirt. There's dirt that things grow well in. I grew up in the Midwest. The dirt just is dark, rich brown there. I live out in California, and the dirt tends to be much more sandy and clayey. But dirt is just dirt. But if you're gonna build things, you need dirt. But even as we look at dirt, we dig in and we see that, lo and behold, we see very similar things. And we see, just how great is our Lord and abundant in power. His understanding is beyond measure. So part of that is, we go out and look at dirt, and one of the things that contributes to getting dirt is plate tectonics. If there were no plate tectonics on our planet, all of the landmass would be ground down below the sea level surface, and there would be no continents. Now, on Earth, roughly 2/3 of all life on Earth lives on the continents or on the continental shelf. And so we see the importance of continents to Earth, but as they get ground down, organisms transform rock into soil, and it becomes a place where we can grow things. And what's interesting is, as scientists have looked at what does it take for plate tectonics to work, what you need is two things. One is you need the rigid plates that can float around, on top of the second thing, which is this kind of more malleable fluid substance underneath. And it turns out that when you look at how Earth is composed, that we tend to think of water dissolving things, but water actually can dissolve into things. And when you look at how readily water dissolves into things, if you look at the plot there on the right, there's some stuff that goes on right on up at the surface. But as you kind of go down, it goes to the right, which means water is more and more dissolving into things. But right around 100 kilometers down, this graph moves back to the left, which shows that water is increasingly less soluble in this 100 to 200 kilometer depth. Well, that does two things. One, that's the depth, so that above that, you've got these plates that are about, on the order of 100 kilometers thick, which is what you need to have good plate tectonics that is not too much and not too little. But there's a particular type of substance down there that causes the water to not dissolve into the rocks there, so it becomes more malleable, but it also draws water from the plates above, and so it makes the plates more rigid, and it makes this malleable substance underneath so that the plates can move around and we get plate tectonics. And if Earth were larger, this region would be closer to the surface and the plates would be thinner, and that would make for far more tectonic activity. And if the Earth were smaller, this would be much deeper and the plates would be thicker, and they would lock up more rapidly. And interestingly, when we go look at Venus and Mars, we see that their smaller size shows just this effect. So we see, again, even in looking at our dirt, we see evidence of fine tuning in there. And as we look at the types of things that are in the surface of the Earth, we see these incredible sandstones and crystal structures. And this was from a time when I was at the Natural History Museum in Washington, D.C. And there's just this room that has incredible displays of all sorts of different minerals and crystals and elements and rock formations that are formed within the Earth. So there's this beauty that we see, but also we just kind of recognize just how powerful it is. you know, when, I mean, we can talk about maybe predicting when a volcano happens or when an earthquake's going to happen, and we're working towards that. But these are things that wreak just incredible havoc, bring incredible power to the surface of the earth, far beyond anything humanity is capable of doing right now. And you know, we see that in terms of the occasional volcanic reaction that goes off, or the occasional earthquake. But these are enormously powerful processes operating within the interior of the Earth, and we see that as we go out into the cosmos. We see incredibly powerful earthquakes on the surfaces of neutron stars. We see supernovae that give off more light in just a fraction of a second than the entire output of the sun. We see these incredibly powerful processes, and it points to a creator who is incredibly powerful. And so, as we've thought and kind of pondered through what would a day look like on another planet, we see these very three mundane things, water and air and dirt, point to how our earth and our universe are fine-tuned, how there's a creator who's invested his creation with beauty, and a creator who's powerful beyond all measure. And this is the kind of creator we get to worship. Now, I like to spend a lot of time talking about categorizing how many different kinds of things. And so I just kind of throw out a question for you. How many different kinds of people are there? You know, we could talk about that in terms of how people respond to viruses. We could talk about that in terms of whether people see a creator or not, or lots of different kinds. And you know, this is my assessment of how many kinds of people. There are those who understand binary and those who don't. A little bit of levity there, math humor for those who like it. But really, kind of the point I want to get to as we look at all of this, that we live in an incredible universe, and Earth hosts a abundant, thriving, diverse array of life that small animals, large animals, fast animals, slow animals, intelligent animals, instinctual animals, all sorts of things out there. And as we look at how they all work together, what are the processes that allow Earth to host all that? What kind of universe does it take to have a place like Earth where it can all be? It just points to a God. Oh Lord, our Lord, how majestic is your name in all the earth. You have set your glory above the heavens. And I find that fascinating. I enjoy what we get to see. And I hope you enjoy just hopefully seeing some of how creation reveals God's majesty. So we're going to stop formally giving a presentation. I know there are some questions that have arisen here. So I'm going to kind of work through some of those questions. We got one from Tim Boyle. It says, what kind of telescope would it take to be able to get direct info from such a planet? How big would it have to be? That's a great question, Tim. And I will say this, kind of the challenge we're dealing with is stars that host planets are a long ways away. The closest star to us is 4 light years. In other words, it takes light traveling at the speed of light 4 years to get from that star to us. Now, to give you a sense of how far away that is, light travels from the sun to the earth in just over 8 minutes. So take 8 minutes, figure out the factor of that to get out to 4 years, and we are 93 million miles away from the sun. And so that's the closest star out there. Now, in terms of seeing the light from a planet, I don't have a picture of one, but if you've ever seen lightning bugs or fireflies, there are these little bugs that their rear ends light up. They give off kind of a yellow-green light, and they're visible only at nighttime. That's right, they start doing that, and they're only visible for a little while because it's got to be dark enough that you can see them. But if you can imagine taking this relatively small light of this lightning bug, putting it right on the edge of the most powerful searchlight we've ever built, you know, like the ones that lit up where the World Trade Centers were, that sort of power, and say, now build me a telescope that can find the light from the lightning bug in amidst that huge beam. That's the sort of technical challenge we're up against. Now, so the difference in light, there's about 1 billion times more light in the searchlight than there is in that lightning bug. So you got to be able to find those few photons of the lightning bug in amongst this incredibly powerful beam. And you also have to now not just get a few of those photons, but you have to be able to get enough of those photons that you can resolve features on the surface of that small planet, which we're seeing from an incredible distance away. As of right now, we've only been able to resolve surface features of a few stars, and stars are 100 times, or have a surface area about 10,000 times larger than the Earth. So that's the kind of thing that's the kind of telescope you have to build. That's why I'm not particularly optimistic that it's going to happen in my lifetime. I'm just not even sure what the technology is that you would use to do that. It's clearly got to be built out in space because the atmosphere of the Earth would distort things way too much. But so that's hopefully that gives you a sense of how difficult that challenge is, Tim. Question from Michael Hirsch says, can you explain how the universe can be an expanding bubble? So I'll offer a few comments on that, Michael, and I don't know whether it's going to directly address your question. But so the picture that astronomers have of our universe, and I'm going to have to shrink it down to 2 dimensions so that we can get a handle on it, is, imagine if you were on a sheet of paper, and this paper just stretched out infinitely long in all directions. So for our universe to expand, all that's going on is that sheet of paper is expanding. And so it's expanding and getting larger. So to the people that live within that sheet of paper, there is no up and down in that. There's just life on the sheet of paper. So there's left and right, or forward and back, and left and right. That's all there is. There is no up and down. Now, that would be a universe with a flat geometry, and we're pretty close to flat. So maybe a little bit better picture, one that might help you get understand a little more, is now imagine that piece of paper actually folds around and it becomes a sphere of some sort. Again, the people on the surface of that sphere, they only know left and right and forward and back. They don't know up and down. 3-dimensional beings that we are, we can talk about up and down because we exist beyond that. But for those beings, all they know is front and back, left and right. There is no up or down. And so what they can do is look at their patch of that sphere, and they can see that it's growing larger, like we see in our universe that it's growing larger. Now there's this, so that's what the basic picture of how our universe is expanding. We know it's growing larger, but it's not like it's expanding into something or whatever. We just know that over time it's getting larger. Now astronomers do have this question: is our universe a closed sphere, a 3-dimensionally closed sphere, or is it the flat sheet of paper, or is it more of a saddle? And the short answer is our best measurements to date say it's flat, but the error bars on that include the saddle and the ball. And so it's flat with error bars that are either open or closed. And so that's an ongoing study of trying to figure out what is the geometry of our universe. But what we do know is that out at least to 2 or 3 places of the decimal, our universe measures like it's a flat geometry. Although I have this suspicion that we probably live in a closed geometry because the error bars tend to be a little larger on that side, but that's kind of an intuition. That's not what there's not scientific data that validates that intuition at this point. Question from Doug Bolin. Doug Bolin. It says, if a human inhabitable planet was confirmed around another star and we needed to move there, how long would it take to get there? I've heard a minimum of 45,000 years. That's basically, given our current technology, that is correct. So we can ask the question. We've launched space probes in various directions: the Pioneers 10 and 11, Voyager 1 and 2, and they're going out into the deepest recesses of space. And given their current velocities, we can ask how long would it be before they are closer to another star than to the Earth, or to the sun. And it turns out that it'll be 40,000 years before they're closer to another star than to the sun. And it'll take another 40,000 years for them to actually get to another star. So we're talking tens of thousands of years, given our current technology. Now, there is a question of, could we develop technology that would allow us to travel faster through space? So, like I said, the closest star is 4 light years away. Could we develop technology that would allow us to travel at maybe 1/10 the speed of light, or maybe 100th the speed of light? Well, if we can go at 100th the speed of light, we can travel 4 light years in 400 years. Or if we're at 10 times the speed of light, we can get 4 light years in 40 years. So it's a little bit of a hard question to answer. What might we be able to do in the future? I think it's an incredible challenge to be able to travel at those speeds, but I'm also a little hesitant to bet against humanity. We seem to be pretty creative, and if it's possible, we've often figured out ways to do things. But as it stands right now, we're talking enormous timescales, generational, in fact, civilization type life scales, timescales in order to get to another star. Philip Eppert asked, how does one measure tectonic activity on other planets? For planets outside our solar system, we have no clue. We don't have any way of doing that. For planets within our solar system, we've actually put seismometers on both Venus and Mars and been able to measure them. Some of the early probes launched by the Russian space program hope to put 3 different different probes on Venus and on the NASA and the European Space Agency have put probes onto Mars that are able to measure tectonic activity, and we can see that there is some level of tectonic activity. We have measured small earthquakes, but it's nothing like what happens here on Earth. The other way we can measure it is we can go look at, for example, when we go look at Mars, we see that there are these very large volcanoes. Well, volcanoes happen over hotspots. And so the way you get very large volcanoes, and by large, I mean take the largest volcano on Earth, like take the Hawaiian Islands. If you measure them down to the base of the ocean, I think they're about 7 miles tall, something on that order. And they're maybe 22 miles wide, something like that. On that order. But when you go measure these volcanoes on Mars, they are 22 miles high, 20 miles high, and hundreds of miles wide. What that says is that these hotspots have been, the plates have not moved over the top of the hotspots. They're in the same place and is just growing and growing larger and larger. So that's one way we have a measure of tectonic activity. And the other, for example, when we can look at Venus, we can actually just go measure the ages of the surface of Venus. And we've got probes that have allowed us to measure ages of the surface of Venus. And we find that it was resurfaced, I think it was somewhere on the order of 1 billion years ago. And I may be drawing, or I may have that number wrong. It may be closer to 2 billion. It may be closer to 500,000 or 500 million. But the point is that we can tell that the entire surface of Venus is relatively new, which that would happen in some sort of catastrophic tectonic event where a whole bunch of magma welled up and covered the surface of the planet. So those are some of the tools that we have to get a handle on the tectonic activity that is happening on other planets. Question from Chris Doctor. It says, what do you think about colonizing planets? I've heard that our solar system is actually favored for space travel. That's a really good question. And, I think from the aspect of, could we build colonies on other objects in our solar system? I think it's possible to do it on the moon. That's challenging because there's no atmosphere there. So we would have to take all of the structures and we would have to build structures that provide an environment that is very stable, and that's hard to do. That's what disaster movies are made out of, is places where we've got these things built underwater or things built out in space, and you get a hole, and it just it's catastrophic to all the inhabitants because you can't repair it, and it just causes the environment, the atmosphere, the air that the humans need just goes away, and people die very quickly. And so that's a big challenge on the moon and even on Mars. So Mars has an atmosphere of some sort. I think it's about 50 times less dense than the top of Mount Everest. So it's still a very sparse atmosphere. But whatever you're going to do, you're going to have to do some sort of terraforming. You're going to have to convert the ground into something that could be able to grow plants. The Martian hinted at that. It's a very difficult thing. There are no other places that have the nutrients in the ground that allow stuff to grow. That's part of what the life here on Earth does. It's not just like life takes whatever's here on Earth and makes it. Life actually transforms this planet so that it's habitable. And so it's a pretty difficult thing, but I also wouldn't be surprised to see us do that. Although the one challenge we will have to deal with, especially if we're going out to Mars, is that those first trips may very well be one-way trips, that it's not like we're going to get out and then be able to bring the person back. And so, could we be able to supply a colony out there for long enough that we could get things so that we could bring people back, or have trips where we can come back? So it's a pretty challenging technical thing, but again, I think it's a fascinating endeavor to go out and look and see, is this possible to do, and how might we go about accomplishing that in a way that actually can take care of the humans that are involved, and we're not just sacrificing them in the name of trying to accomplish a goal. Another question: can you explain the hexagon storms found on Saturn and Jupiter? I am just going to have to confess, I remember hearing about these. I remember looking into them briefly, and I don't have an exact answer, but my recollection was, so you got these very strong wind patterns on the planet. And what that means is that you end up with various cells of or air masses that have various sizes. And as you try and push them together, just the same way as you push bubbles together, when you push bubbles together, you tend to get hexagonal shapes if you put them together in certain ways. And so it's something related to the size of the cells, not the flexibility, that's not the right word, but how compressible they are. That it's something related to that, but I'd have to go back and look at the details more in order to explain them. But I do know you get these very strong wind patterns on both on Jupiter and Saturn. And so you got these large air masses that are moving around, and it's just how they're pushed together inside those flows. That's what causes that hexagonal structure. In fact, when you look out at things that are liquid, that are solidifying, or things that are being pushed into shapes, they tend to do hexagonal shapes, because that's one of the symmetries that a lot of the underlying molecules have. Jennifer Burton asks, is there a scenario under which air and water would not be required for life? Any sort of life with which we're familiar, the answer would be no. Water is so even if you get down inside the cell, the water is the medium by which all of the biochemistry that life requires happens. So, and that's true universally with all life we've ever detected. So if that were the case, it would have to be an entirely foreign kind of life. Now, inside our universe, I doubt you're going to find that, because there's no other molecule like water that can allow all of those biochemical reactions, that can dissolve enough materials, that has a high enough heat capacity, that has just all of the properties that medium for the biochemistry to happen is going to have. There is no other substance like water known in the universe. And so, no, I can't think of an environment or scenario in which air and water would not be required for life. Now, there are organisms that don't actually need the air, that they can extract nutrients from the rocks and things like that. But if you're talking about animal life, any sort of complex multicellular life, you're going to need something like air, because that's the mechanism by which you provide the energy. And the reason why oxygen is important is because oxygen actually has a lot of stored energy, there's a lot of energy that can be extracted from oxygen to fuel large-bodied organisms or multicellular organisms. Question from Marge Harmon. It says, I've heard it said that there is no center to our universe, but if we're expanding from a singularity, wouldn't that singularity be at the center? Yeah, that's a very common question that Marge asks. And the short answer is no, because the singularity actually is everywhere in the universe. So if we go back to our picture of the ball that's expanding. So we've got a ball, again, inhabitants are just on the surface, and as it expands, the inhabitants can actually measure the size of their ball getting larger, the size of their universe getting larger. But now let's just imagine running it backwards. As you run it backwards and backwards and backwards, it gets smaller and smaller and smaller. There is still no center, because again, for the inhabitants in that universe, all that exists is forward and back, left and right, and there's no center anywhere on that ball. As you run it further and further back, eventually it just gets to where it's all into a single point. And that single point, or that singularity, I don't even use the word point, it gets to where it's in a singularity. And that singularity, so now if we run it forward, that singularity expands and it becomes the entire universe. But that singularity, or every point in the universe, was part of that singularity. And so I know that's a little bit of a hard concept to get your mind around, but that's the short answer is the singularity isn't everything started there and expands away from the singularity. It's that the singularity is what you run into if you run for wherever you are in the universe. If you run time backwards, eventually you run into that singularity. Every point in the universe runs back into that singularity. That singularity need not be a point. It can actually have a lot of dimension to it. And I know that's just weird and bizarre, but that's what the mathematics tells us about how that works. So it looks like maybe the last question here. Chong Ho Yu asks, if aliens from another planet really exist, how would it affect Christian theology? Divine creation of a unique planet, Earth, and the human race? And that's a great question, Chong. And I'll say this, or I'll explain it, or I'll tell you why I think it's a good question. Is because as I began to get into science apologetics, often the way I heard arguments for fine tuning and how unique Earth was is that Earth is so unique, we would not expect to find another planet like it anywhere in the universe. And kind of the implication being is that if we found another one, Earth isn't actually that unique, and therefore there's no God required for it. And as I thought about that, especially as I've been thinking about looking for life in the universe and how do we argue from fine tuning, what I've recognized is that the argument is it places the emphasis in the wrong, or it puts the emphasis in the wrong place. What I would argue is that when we look at Earth, it has all the signatures of being designed and tuned for life to be here. If Earth were the only thing that existed, well, I guess I'll have to go with the solar system because it relies on the sun. But if the solar system was the only thing that existed, I would still look at that and say, wow, given what we know about physics, this planet is so well designed that it looks like there's a creator. Now, let's go out and look into the universe. If we go out and we find another planet in the universe, does that mean, well, Earth just kind of randomly happened through the universe? Or more likely, does that mean that God has gone another place and said, here's another place where I'm going to put life? And so that to me is a very theologically interesting question. So part of your question was, how would this impact Christian theology? Well, I mean, your essence or your fundamental parts of Christian theology you got creation, the fall, the incarnation, the resurrection, and the eternal state. And so, if we found other places like Earth where there were bacterial life, that would be interesting, but that really doesn't impact any of that. Doesn't impact any of the essential parts of the Christian narrative there. But if we found other sentient beings, now the question is, what does that mean? Because we've got, Christ died for our sins here on Earth once for all. How does that integrate with Christian theology? And I will just leave you with this, that Christians, long before we even had the potential to go out and explore whether there was life in the universe, we've been doing science for roughly 400 years. For centuries before that, Christians have thought about this idea. Is there life out there, and how would that impact Christian theology? In fact, I kind of jokingly say it wouldn't surprise me to find that Adam and Eve were in the garden arguing about whether there were extraterrestrials. It just seems like it's that interesting of a question. But long before we started scientifically exploring this, Christians have thought about this, and they've come up with different scenarios or different ways that it might work. For example, it could be that there are other creatures out there, other sentient beings, but they've never fallen, and so they're in no need of redemption. And God is still the God, and Christ is still their King, just the same way. It really doesn't have much of an impact at all. Or it could be they're fallen, but there's no means of redemption. That's kind of like what we see with the angelic realm. Or it could be that they're fallen and God has a different means of redemption. Or it could be that they're fallen and they need redemption, and Christ's death and resurrection here on earth pays for everybody's sins across the universe. Or it could be that they're fallen, they need redemption, and Christ becomes incarnate on their planets as well. We take, the kind of how that would play out in my vision is that, we've got, or we're created in God's image. We're made in His image. but we don't fully reflect his image. So maybe there are humans, Christ took on a human nature, but he also took on a Klingon nature, something like that, where, so these are the kind of scenarios that people have thought up, and there are challenges and difficulties and things to wrestle with each one of those. But the thing I would say is this, is there's this common assumption that if we find life out there in the universe, especially sentient life, that means all the world religions are just wrong and they have to rewrite things. And especially, especially that's true of Christianity. And that's just not the case. Christians have thought about this for a long time. And one example of that is people say, why the aliens come, land on the White House lawn, and they come out, that means that Christianity's wrong. Well, there's a presumption in that scenario, because that means the aliens would come out and we'd ask them, and we'd ask them about what do they know about God, and they would say, well, there's my shield went down, so I got a little washed out there. But they would say, well, we don't know anything about that God. Well, if God is who he says he is, why would we expect that? Wouldn't we expect they would come out and give largely a similar account to what we know of God? Because God is a God of consistency and reliability and trustworthiness. I would expect them to know a similar story about God to what he's revealed to us. And so I think there's a lot of interesting theological and scientific studies there. So we'll go on to Mark Zachman. Says, I know that once we get outside of our magnetosphere, that also protects the moon, the radiation levels are very high. Is there any conceivable way around the significant problem to travel to, say, Mars? So the short answer to that is yes, there is. We've actually measured the radiation levels, Earth, on the trip to Mars and on the surface of Mars. And so we know what we're dealing with. Particularly when you're on Mars, you could actually build habitats down underneath the surface so that the surface is, and you have to go, a few feet down underneath the surface, and that will provide the shielding. And you could presumably build spacecraft with a little bit better shielding, or more likely you could develop drugs that would counteract the effects of the radiation while you're traveling. But you do raise a very good point, Mark, is that Earth's environment, Earth's atmosphere and magnetosphere provides a great shield for the inhabitants here on life. And when we get out into space, it gets hostile really quickly. And so, it's not like we can just go travel out there somewhere. We actually have to deal with all those radiation issues. And I'm not going to say it's impossible to deal with them, but they are big challenges to deal with. So we got Irk Ashby asks, in the movie The Martian, the stranded astronomer raised potatoes. I think Dr. Ross said this wouldn't be possible in Martian dirt, I think. Do you recall why? Well, in part of the reason why you can't do that in Martian dirt is we think Martian dirt, and when we think dirt, we think like Earth. Earth's dirt is filled with nutrients and bacterial and lots of decayed organisms. It's an environment that readily allows things to grow. When you get to Mars, Mars has different sized pebbles, but it doesn't have all the nutrients and other mixture in there. And if you recall, on the Martian, he didn't actually just take the dirt. He actually took the dirt and seeded it with all the nutrients that were going to be necessary for that. So, it's a little bit more complicated process. You can't just take dirt and make it work. But so there's this ongoing question. People have actually tried here on Earth to say, here's what we think happens in or Mars soil looks like, and can we reproduce that, and can we grow stuff in a Martian environment here on Earth? And they have been able to grow stuff at some level. It's unclear to me how applicable that actually is to the Martian surface, but people are looking at that, and it does seem like it will be possible with a lot of engineering to maybe be able to grow some stuff that would allow some sort of physical sustenance there on the surface of Mars. Another question from, it says, let's say we have the ability to go and live on another planet. Would God be okay with this? Or are we only meant to be here? Basically, what do you think? I think God designed this planet for us to live on. And I also think he gave us a spirit of exploration. I don't see any other reason why we want to go figure out how to cross the Antarctic continent, or how to climb to the top of Mount Everest, or how to go to the moon. So I think it actually does please God when we use our creative abilities, our ingenuity, and our desire to explore to go out and understand his creation. I think what we need to be careful of is thinking that somehow by doing this, we're in control of everything that goes on and that we don't need God. The reality of it is the tools or having a creation that is reliable enough that allows us to get there is ultimately anchored in God's character. Our ability to think about our place in the cosmos is actually very well founded in Christian theological thought. And our desire to go out and explore is ultimately anchored in God's charge to Adam in the Garden of Eden to go out and be fruitful and multiply and rule over the earth and subdue it. That he has given us the universe that allows that kind of exploration, given us the tools to go do it and the consciousness to do it, and the ingenuity and the mandate to go out and do it. So I think, yes, I think God is pleased by our exploration of his creation and the possibility of maybe being able to colonize other planets. I have one from David LaRosa asked, is it possible that life is written in the laws of nature as some propose, making life inevitable in the universe? God simply set the initial conditions in motion for its efflorescence. I think there is some possibility to that. And so there's, as a Christian, part of what I wrestle with at times is, did God design things so well so that just once he starts, they could play out and happen all along? Or does God intervene routinely throughout the course of things? And there's kind of two extremes there. One is that God just started it and let it go and he never intervenes. And the other is that God's intervening everything to making everything happen. And it seems to me the Bible describes kind of a mix of those two, that there's this divine providence, that God upholds creation without, if God were to withdraw his hand, it would tumble into non-existence. So he's intimately involved in everything that goes on in creation. But he also lets things play out according to that plan a lot, and at times will intervene to make extraordinary things happen. I would be a little bit uncomfortable with the God wrote life into the laws of nature for two reasons. One is that it kind of makes God very distant, or it leads to God being very distant. But more than that, we talk about the universe being friendly to life, and it is in the fact that its basic laws of physics permit life, but the universe is actually relatively hostile to life. The conditions on Earth are unusual compared to what we see when we look throughout the universe. It's a very narrow temperature range in incredible cold to extreme heat. It's a relatively small size given what we see in the cosmos. So the conditions on the surface of the Earth are relatively unusual. And to me, so that says that I don't know that life is written into the cosmos. I think life is, or the cosmos or the universe is designed so that it can prevent life. But I'm inclined to argue that apart from God's intervention, it wouldn't happen. So last question here from Rebecca. It says, we've seen lots of things about UFOs in the news recently. Have you seen this? What do you think it makes the case, or have you seen this? What do you think it makes about the case for life beyond Earth? So the things I will say is this. I've seen bits and pieces of that. This has been going on for my entire life that I'm aware of. People have been claiming, oh, we see UFOs here or there. The reality of it is travel through the universe is incredibly difficult. I am highly skeptical of any sort of UFOs, in part because finding a place where life could exist is incredibly difficult. Partially because the possibility of traveling throughout the universe is incredibly difficult. And because a lot of these UFOs, we often end up finding explanations for. And the ones that we don't find explanations for tend to violate the laws of physics and have a ready explanation or seem to match the way demonic activity works. So I'm not going to make a definitive declaration on that. I don't know whether God's created other life in the universe, and I don't know whether he's given it the capacity to travel through the universe. I'm skeptical that that's the case for the reasons that I've outlined through here. But I guess I would say this. I would be careful of any UFO claim. And particularly, be very skeptical and be very cautious about investigating it, because if Christianity is right, and I'm convinced it is, that we live in a world where God is ultimately in control, but it's also this battleground between God and Satan. And Satan is not described in very pleasant terms. He's a roaring lion out to devour you. And I think this is one area that opens you up to his influence that will devour you. And so I would encourage you to be very careful. And if you want to probe that a little bit more deeply, we do actually have a book at Reasons to Believe called Lights in the Sky and Little Green Men, where Ken Samples, Mark Clark, and Hugh Ross all look at that from an astronomical perspective, from a philosophical, theological perspective with Ken Samples, and from a defense intelligence agency perspective by Mark Clark. And I think he gives a great picture, great summary of how to think well about that particular topic. Well, I appreciate you taking the time to enjoy or hang out with us today. I would encourage you to go look down in the links below in the description. You'll get some information about resources and the slides that will allow you to explore this topic more in depth. Would invite you to join we're going to do a podcast. We're going to answer some even more questions after this, which you can subscribe to as our monthly podcast. Again, more information down in the show notes or in the description below here. Would encourage you to look into that, come back and join us. And just thank you for joining us today. And I hope you have been inspired to see the glory that God has revealed in creation and to be worshiped to and drawn to and worship him more.